Hello everyone, welcome back to cyberLKC. So it's day 5 of hacking journey with Black Hat Python, and today we are going to start a new topic with new experience and with new energy. So let's see what we will cover today. So we are going to cover writing a sniffer in this chapter. So what are sniffers? And basically in network terms. So network sniffers allow you to see packets entering and exiting a target machine. They have many practical uses before and after exploitation, and in some cases you will be able to use existing sniffing tools like Wireshark or Python based solution like Scapit library. So there is an advantage to knowing how to throw together your own quick sniffer to view and decode network traffic. Writing a tool like this gives you a deep appreciation for the mature tools, as this can take care of finer points with little efforts on your part, and you will be also likely to pick up some new Python techniques and perhaps a better understanding of how the low level networking bits work. In the previous chapter we covered how to receive and send data using TCP and UDP, and this is likely how you will interact with the most network services. But underneath these higher level protocols are the building blocks that determine how network sniffers are sent and received. You will use raw packets to access lower level networking information, such as the raw internet protocol or IP protocol, ICMP headers, and more. So let's begin with a brief walkthrough of how to discover active hosts on a network segment. So for now we are just covering the theory part of how building a sniffer UDP host discovery tools work. Our sniffer's main goal is to discover hosts on a target network. Attackers want to able to see all the potential targets on a network so that they can focus their recon and exploitation attempts. So when we send a UTP datagram to a closed port on a host, that host typically sends back an ICMP message indicating that the port is unreachable. This ICMP message tells us that there is a host alive, but if there was no host, we probably wouldn't receive any response to the UDP datagram. So why the user datagram protocol? Well, there is no overhead in spraying the message across an entire subnet and waiting for an ICMP response to arrive accordingly. This is quite a simple scanner to build. Most of the work goes into decoding and analyzing the various network protocols headers. We will implement this host scanner for both Linux and Windows to maximize the likelihood of being able to use it inside an enterprise environment. So let's see next. So before diving into coding part, let's understand or what a network sniffer tool looks like. So it's a result of the Wireshark tool, which is a mostly used tool for network sniffing. So as you can see, here is the number and time on what time we receive, and main is the source, destination, and protocol. So source is the from which the packet receives. Either can be like it our own device, or another device can send packets to us. That will be a source, and destination is where the packets are going, and main is protocol. What kind of protocol is going to use? UDP based, TCP based, ICMP, HTTP, HTTPS, and more. This is how network sniffer looks like. So let's continue for our next. So this is going to be a practical coding part. We will cover packet sniffer on Windows and Linux. The process of accessing raw sockets in Windows is slightly different from than on its Linux. So but we want the flexibility to deploy the same sniffer to multiple platforms. To account for this, we will create a socket object and then determine which platform we are running on, as Windows require us to set some additional flags which enables promiscuous mode on the network interface. So let's understand. In our first example, we will simply set up our raw socket sniffer. So let's start for coding. So this is our Black Hat Python folder. Let's run our terminal for executing the VS Code. So let's create a new file for sniffing. So we are going to use the same libraries for now, socket and OS. First define the host or source. This is my local IP, and let's write our main function. We are going to define in main function that our OS is Windows or Linux. If our OS is Linux, it will use ICMP protocol, and if our OS is Windows, then it will use IP protocol. Let's set up that. So this is for Windows. And this is for Linux. So let's set up our sniffer. Now including the IP header in the capture packet. If OS dot name is NT, that means for Windows, it will use this IO control. Now let's print one packet. So if we are on Windows, then we need to turn off promiscuous mode. For that, we are going to code and let's call the main function. So let's understand what we have done. Firstly, we have defined our host for our own system and constructing our socket object with the parameters necessary for sniffing packets on our network interface. Then the difference between Windows and Linux is that Windows will allow us to sniff all incoming packets regardless of protocols, whereas Linux forces us to specify that we are sniffing ICMP packets. And we are using promiscuous mode, which requires administrative privileges on Windows or root on Linux. Promiscuous mode allow us to sniff all the packets that the network card sees, even those not destined for our specific host. Then we use a socket option that includes the IP headers in our captured packets. And the next step is determine if we are using Windows, and if so, perform the additional step of sending an IO control to the network card drivers to enable promiscuous mode. And if you are running Windows on virtual machine, you will likely get a notification that the guest operating system is enabling promiscuous mode. Now we are ready to actually perform some sniffing, and in this case we are simply printing our entire raw packets with no packet decodings. This is just to make sure that we have the core of our sniffing core working. After a single packet is sniffed, we again test for Windows and then disable promiscuous mode before exiting the script. So let's test our code. Let's save it and start our terminal. So before that, you need to turn on your virtual environment, which we created in the beginning of this course. Let's test our sniffer. Line 10. Here it is IP proto, and it's permission not permitted. That means we need a administration permission for this. First is for bind, we need to use a double bracket. Now let's test this again, but we are using the sudo privileges this time. It's listening. Now let's ping our IP. So as you can see, we captured the 1 packets as we have written in the code. So that's how it works. It can monitor all the packets, but for now we have just captured 1 packets. So that's it for this. We will cover more in next video about the sniffing the packets. So if you like the video, please subscribe the channel and like the video. Thank you.